Alright, welcome back to Miss V Makes It Easier. So now we're going to move on with standard notation. So numbers are shortened via a process known as standard notation. For example, the number 4,000 may be written as 4 times 10 times 10 times 10, which is equal to 4 times 10 raised to the power of 3. The number 0.4 may be written as 4 over 10, which is equal to 4 over 10 to the 1, which is equal to 4 times 10 to the negative 1. The small figures negative 1 and 3 are called a power of 10 or exponent, and gives the number of times the number has to be multiplied by 10 if the power is greater than 1, and the number of times it has to be divided by 10 if the power is less than 1. Please note that any number to the power of 0 will be equal to 1. For example, 10 raised to the power of 0 is equal to 1. 2 raised to the power of 0 is equal to 1. 5 raised to the power of 0 is equal to 1. U raised to the power of 0 is equal to 1. Now, 10 to the negative 3 can be written as 0.001. This is saying 1 is to be divided by 10 times 10 times 10. And 10 to the negative 2 is equal to 0.01. This is saying 1 is being divided by 10 times 10. 10 to the negative 1 is equal to 0.1. This is saying 1 is being divided by 10. 10 to the 0 is equal to 1, as I was saying earlier. And this is saying 1 has nothing to be multiplied by. 10 to the 1 is equal to 10. This is saying 1 is to be multiplied by 10 only once. 10 to the 2 is equal to 100, and this is saying 1 is to be multiplied by 10 twice. 10 to the 3 is equal to 1,000, this is saying 1 is to be multiplied by 10 3 times. Now here we have an exercise, and you're going to only learn how to use exponents, or even you already learn how to do that, but you're going to learn how to do standard notation only if you do exercises. So I'm going to show you how to do these exercises, and then we're going to move on to something a little bit harder, but then everything is going to just eventually be the same after that. You're going to be able to do it naturally, easily after that. So here we go. Here we have 300,000. Okay, if I put a comma there, it will be even easier to read. 300,000. And so, with this, you will notice that the point, you want only one number to the left of the decimal place, meaning that you just want one number. When you're writing standard notation, you just want one number. Okay, so in this case, the point will move here 1, 2, 3, 4, 5. Right, so it will move 5 times to the left. And so you would write here 3, control paste. I'm going to control paste, and then earlier I looked for the multiplication sign, so pretty much I was able to paste it. And once your point, in this case you just have a point here, a point will be here, you know, it's supposed to be here but it's not, so you have to imagine that a point is there, and that point had to move 5 spaces to the left. If you have to move to the left, then your number, your exponent will be a positive 1. Okay, so if you have to move to the left to get a whole number, okay, like in this case, the exponent is going to be a positive 1. So in this case, the exponent was 5, and we're going to raise it up. So superscript, okay. Alright. Now in this case, what do you think is going to happen? In this case, we're going to imagine the point is here, and to get one whole number, we have to move it all the way to the left here. So we go 1, 2, 3. So we have to move it 3 times. So in this case, we're going to end up with 5.9. If you end up with 5.9, the 9 is greater than 4. Once anything is here, so in this case, we'll have the point ending up here, right? So if the number to the right of the decimal place is 5 and greater, you would bump up the number here. The whole number here, you will bump it up. So in this case, since the point moved 3 times, you're going to put that the point moved 3 times. Just put control paste, and we're going to space, and it moves 3 times to the left, so therefore it's positive, and we're going to make it up here, superscript. Okay, so it's positive. And now we're going to place the number that we want here. So if the point from here, move here 3 spaces to the left, you know it's positive. And guess what? If this number to the right of the point is 5 upwards to 9, then this number here will bump up from its original number. So therefore, our number will be 6. Okay? Great. Okay, so I can get rid of this. Now here again, we're going to imagine a point is here. And how many times must it move to be behind to make one whole number? Right, it moves twice. And where does it move? To the left. So if it moves to the left, guess what? It's what? Positive. So we're going to put this and put 2, and we're going to raise it up. Okay? Raise it up to 2. Oh boy. Yeah, mistake. Alright, so superscript. Great. And so now, since if we move the point from here, so the point was here, and then we move it 1, 2, so the point is now here. Note well the difference. The number here is 2, it's below 5. So this will stay as 8. So we'll just put the whole number 8 right here. 8 right here. Okay, good. So now again, we're going to imagine a point is here, moving to the left, so therefore our exponent is going to be what? Positive. So we're going to move it 1, 2, 3, 4. So we're going 1, 2, 3, 4. Let's move there, and the number to the right is 0, so it wouldn't affect the number to the left of the point. So therefore, since we moved 4 spaces ahead, we're going to go ahead and place the multiplication sign there, and it moved 4 spaces. So we know our exponent is positive because it moved to the left, number 1, and it moved 4 spaces. So we have that, and we know that this is going to stay as 1 because the number to the right of the decimal place is below 5. Okay? So therefore our number will be 1. Right? And then here again, what do you think it's gonna be? So now I don't have to put a point to show you, do I? I'm gonna still do it. So you're going 1, 2, 3 ahead, and you put a point right there. So is there anything affecting the number to the left? No, 0 is lower than 5. So right here, we're going to keep 1 and we move 3 spaces to the left. So we know that our exponent would be positive. So moving that up, superscript is positive right there. And we're going to leave, we're left with 1. So we don't have to do anything at all about that. So if you have these answers, great. If you have these answers, great. So I'm going to enlarge the screen so you can enjoy the answers. So we have 3 times 10 to the 5. Is that correct? Yes. We have 6 times 10 to the 3. Yes. We have 8 times 10 to the 2. Correct. We have 1 times 10 to the 4, correct. And we have 1 times 10 to the 3, and I forgot to get rid of my decimal place. Sorry about that. So we are definitely moving along nicely. Great. So let's try the next slide. Our next slide now is filled with decimal places because I want you to get a feel for if the decimal place was there, suppose you didn't have to imagine and the decimal place was there and it was in places that you're not accustomed to. So let's try this together and see if you understand. So in this case, the decimal place, for you to get a whole number, has to move to the right. The decimal place has to move in the first instance. If the decimal place has to move to the right in the first instance, that's your first course of action, you're going to have a negative number. So I'm going to put control paste here, 10. And you know, if you had to move to the right, the first number, it would move once. It's just moving here. So, if your decimal place had to move here to get a whole number, which is 8, right? And it move once, then it will be negative 1. So you want to put here, it move once, it will be negative 1. Here, and the whole number will be 8. Great. Good. So that's that. And note where we get rid of the number. We just only want one whole number with standard notation, unless the directions state that they want 2 sig fig. You really, in standard notation, you're looking for 1 sig fig. And 1 sig fig would only apply to this number here. You just ignore this whole thing. And that would have been explained in a previous video. But again, if you're looking for sig fig, at this point we just want 1 sig fig. That is what I request. And most times when you're dealing with standard notation, it's 1 sig fig they're looking for. If you wanted 2 sig fig, then you would have written that. But I don't want that. And most questions don't want 2 sig figs. Now in this one now, we have the point here, and if you want a whole number, if you don't want 3 numbers here, 3 whole numbers, you want 1 whole number, you move into the left. So if you have to move to the left, what is it? It's going to be a positive number. You move into the left. That's your first course of action. It's going to be a positive number. So if you move here to here, you're going 1, 2. So now you know that you have to move 2 spaces. You move it to the left first, so it's going to be positive. So you're going to be left with, so you're going to put here, you already know, you're not going to waste any time, times 10 raised to the power of 2. Okay? 10 raised to the power of 2, superscript, okay. And now in note, well, if you move this between the 5 and the 6, move this here between the 5 and the 6, what's happening? The 6 to the right is 5 and up, so therefore this 6 is going to affect the whole number 5, and it's going to cause us to bump it up to 6, because the 6, remember, is between, it's from 5 up to 9, that is where it affects your whole number. Okay, let's put the point back to where it was. So this is now our standard notation for this number. Now, is this number fine? It is, but we only want 1 sig fig. So we're going to write our standard notation here the same way. The same way. 3 times. Oh, it's just, we don't have to do anything. We don't have to do anything. 3 times 10 to the 0. Okay. And why did I do that? Because, because 3 times 10, 3 times, no, sorry, because 10 times anything to the, 10 times, sorry, because anything raised to the power of 0 is 1. Okay? So here we have that. We didn't have to do anything else. Okay, for this point now, we're moving to the right first. If you move into the right first, that's the first course of action, then guess what? You're going to have a negative power. So again, we're moving. If you have to move the point, we're going 1, 2. So therefore, you're going to be left back with, just put control paste times put the 10, and we had to move twice to the right. We move twice. Because we have to move to the right, it's going to be a negative number first. Alright. And then, if we put the point here, if we have to move to the right twice, and the point is here, okay? Does it affect, is anything there to affect the whole number that we have now? No. So it's going to be left as 4. Okay? And now for this one, again, we just wanted one sig fig, and so we're going to move this point to the left one time. And if you move into the left one time, or if you move into the left at all, that's the first course of action, you're going to be your power is going to be positive. So again, we're going to stick in our multiplication sign here, times 10, and moving to the left, so it's going to be positive. I'm going to raise that power. That's great. Great. And since it's moving here, is the 0 going to affect it? No, it's not. It's not going to affect it. So pretty much we are good. So we left back with a whole number of 1. And let me just open this up so you can see. Let's make sure we're correct. So if we're moving from here to here, we move backwards. We move to the right, which is -1. We do it once. We move into the left twice, so that's +2. We didn't have to move this, so we could just leave it as, and the 2 that is on the right of the decimal place would not affect the 3, so we don't have to bump up the 3, so we multiply by 10 to the 0. And this we move to the right, and so since it's moving to the right, usually some people say moving to the right is backwards, because we write from left to right, so I'm moving backwards. And so this went back twice, so -2. And since this had to go forward once, going to the left is forward in our book, you just say went once forward. And pretty much if you do more exercises like this, you will get better and better in standard notation. So just make sure you get a book that has elementary math, and you can get better in your standard notation with time. Thanks for watching.